Howdy, Joe here. I'm a bit of a photographer and I live in a place called Vancouver. So Jovan is a label I'm kind of building on. And this is an exercise in communication. Can we talk? That kind of thing. A communications course. I'm kind of learning how to use these tools. And so I'll start with some images and see where we go. Okay. Um, I don't want to be a distraction, so I'll take myself out of frame every once in a while, but continue chatting about the image on screen. And this is a part of a series I'm always kind of um noticing is wet light, the relationship between water and air and light. And it can be gloriously gorgeous. And this one has notes of copper and bronze at the top, and then at the lower right, moving into greens and grays. And that calls to mind copper penny getting tarnished. When copper is in contact with oxygen, it doesn't rust, it's a patina, builds up over time of green. And it's a long, slow process. It can take years. And this is just a little reminder of all that and a spot to begin with. Okay, now I'm gonna change images to a next one. And this shot is from dawn about a month ago. And I'll get out of frame. And so this is looking east, and there's a mountain on the eastern horizon that I can only see when the leaves are off the trees. And it's a little bump um, just to the left of the top of that building. And it is visible, but only just barely. You got to know what you're looking for. But the angle of the sun is throwing the shadow of the mountain across the belly of the clouds. And one can seldom see the shadow of a mountain, and it is immense and kind of a thrilling angle. I'm going to show you another picture of the mountain that shows it more clearly and then come back to this. This is Mount Baker from Little Mountain. And Little Mountain is less than a kilometer high, about 420 meters. But Mount Baker is 3 kilometers high, and it has a large volume of glacier upon it. And it's a volcano that is semi-active, and it's about over 100 kilometers away and it's in the States, just the other side of the 49th parallel. Vancouver's just north of the 49th. And so it's a glimpse of another country from here. And gosh, um, ah, so I could say a lot about Mount Baker, but one thing that pops to mind is that's a lot of ice. It's almost 2 cubic kilometers of ice on top of that mountain. Um, and when a volcano goes, most of it's converted to water, but a significant portion is converted to steam. And the density differential in between ice and water, which have very close to identical volumes, when converted to steam, that volume is multiplied by 1,600 times. And that's a lot of pressure. So if just 10% of that ice gets converted to steam, that'd be, gosh, let me do some arithmetic. So let's see. Oh, right. Camera needs to readjust, bring those levels back into. So it's 1.8 cubic kilometers of ice on top of that mountain. And rounding up to 2 and then taking 10%, as in 0.2 cubic kilometers of ice turned to steam times 1,600 in the change in volume is 320 cubic kilometers of steam. That pressure wave would eliminate most of the city's glass. All the windows would shatter. And that's not even getting into the structural or we're quite a long way away, over 100 kilometers. So lava flows and lohars, um, mud, water, rock slides probably wouldn't reach this far. But that pressure wave is extraordinary. And volcanoes can be dangerous, as can life. Um, anyways, I just wanted to show a glimpse of Baker a bit clearer, and then going back to the earlier image. Okay, so another thing about this image that kind of grabs me is that it shows kind of the world turning, because the image of the because the shadow of the mountain on the belly of the clouds is a rare thing and only lasts for moments because the whole world is moving. We're the world spins on an axis toward the east. And I've learned that the speed of the planet's motion in its twirling at the equator is about 40,000 kilometers, and you divide that by 24 hours, and you get about 1667 kilometers an hour as a constant speed at the equator. But we're not at the equator. This is in between the 49th and 50th parallel, which is a line that is considerably shorter than the equator. And if you were to go all the way up to the North Pole and the axis point, speed would go down to 0. So it's somewhere between that and 1600 kilometers an hour. And I did some digging and figuring, and it's closer to 1125 kilometers an hour between the 49th and 50th parallels. And I might be off by a bit, but that's a pretty good clip. And geez, I'm not even sure how it rates. It's probably faster than the speed of sound, but maybe only just barely. And so and so we're spinning toward the east, and the whole sky is moving westward. And along with our rotational velocity, there's also our orbital velocity. And that's a little over 100,000 kilometers an hour, 107-ish. And the 1125 of rotation gets added to or subtracted from the orbital velocity. I think in these ways that at noon, orbit and rotation add, so it's 107 plus 1100, no, 107,000 plus 1100. It's adding less than 1%. And so that happens at noon, and at midnight, it's a minus. Maybe I'm just splitting hairs here, but it's interesting details about motion. Because whoops, a bit of a light flare. Takes a while for the camera to adjust. Why I mention speed of motion is because of the wheelchair. I'm mostly a homebody. I don't get out much or travel much in the usual ways, but I do get around in numerous ways, and it can be an adventure. And so I like to be able to share a capacity for travel with a point of view. And a point of view can be an incredible thing. So on to the next. Next, here is a pond with some stones and a gull and a lot of greens reflected in the water. And those greens feel rather painterly, brush strokes. It's almost hard to believe it's a photograph. There's so much diffusion and dispersion among the color, but you can feel the ripples and the motion in the air, and it's quite lovely. Cons call to mind two obvious people, precedents. One is Thoreau. Thoreau is Walden, about a person who lived by a pond for years and observed things. And the second is Monet, who spent years painting pictures of ponds. Well, his water lily series, of which he did many, many canvases. This was a topic he returned to many times. And the gull calls to mind, to me too, a third topic is Jonathan Livingston Seagull, a book from my younger days, and the inspiration of it. So how many things might you see, connect, feel about some of the things here? One is that it's showing a bit of bird poop on a stone, as in shit happens. Life has wastes, and that's a part of the part of the scene. I'm kind of gosh, maybe this will be a rehearsal tape, and I'm gonna have to actually write a script up for this to keep myself focused and coherent. But also the pond calls to mind all those miniature life forms that live in water and how we came to learn of them. There's a cosmos in a pond drop of so many life forms. And so along with Thoreau and Monet, there's also Leeuwenhoek is a Dutch scientist who itemized a great many of the life forms in a pond. But also, before Leeuwenhoek, there was Robert Hooke at the Royal Society, who wrote one of the first best-selling books in science is Micrographia, and he drew drawings of things that are small, like a flea or a louse, or some pond critters. But the pond, well, Robert Hooke did do some, Leeuwenhoek did more. But there's a lot of life forms out there, and looking into the small, the closer you look, the more you see. As with looking into the big, the closer you look, the more you see. And here is the same pond from a different angle. And I don't know that it's the same day. It's unlikely to be the same gull, but it's not impossible. But The reason why I bring this to your attention is the three trees across the pond are dawn redwoods. And it's a remarkable story, the dawn redwood or metasequoia. You can look it up on Wikipedia. This species actually goes back more than 150 million years with relatively little change. And it's closer than a cousin to the two California redwoods, the coast redwood and the Sierra redwood up in the mountains. And oddly, the dawn redwood is deciduous. It drops its needles in the winter. So it's an unusual species. But also, it used to be dinosaur food, and it used to cover a major portion of the planet 100 million years ago, 150, maybe even further. And fossils, it is a part of the fossil record from around the planet. And fossils of it are to be found on Ellesmere Island in the Canadian Arctic archipelago. And scientists had long thought it long extinct. It was unknown in life up until in between the Second World War and the Mao's march in 1949, the Chinese Revolution closed the country again. In between one war and another, botany specimen explorers went into and discovered in a Chinese Himalayan, the northern Himalayan valley, which was filled with them. And they were propagated across the planet from samples found in the late 40s that were sent to Kew Gardens in London and another botany collection in Boston. And they were spread around the world by gardeners. And they're actually quite beautiful. And they're a glimpse of older life. So, again, a light flare to adjust. There we go. And so that's going to be what I'm going to be saying on this particular recording. I'm learning how to do this, and it's going to take a bit to figure out how to crop, publish, share. Lots of steps along the way, hey? Good to meet ya. Hey, do, and more to come. And be well. Ciao.